Common maneuvers. Some of the common ship handling maneuvers are described in this module. The short round turn. To turn a single screw vessel in her own length in calm waters, the procedures are as follows. The engine is reversed. A swing to starboard develops. The engines are stopped, and then worked ahead with full starboard helm. At the first sign of headway, the helm is put midships and the engine reversed again. This procedure is repeated until the vessel completes the turn. Dredging down. Drop anchor underfoot. This term is used when the vessel moves under the influence of the stream with her anchor held at short stay. In other words, the anchor is dropped length about 1 to 2 shackles. Her speed over the ground is retarded and she will respond to helm. To dredge to port, the starboard anchor should be dropped and vice versa for dredging to starboard. Dropping down. The vessel drops down when she drifts with the tidal stream with the anchor just of the bottom. Turning on an anchor 1. When heading with the stream astern, the vessel is turned by letting go the anchor underfoot, 1 to 2 shackles depending on depth of water. Anchor is allowed to drag at the bottom. Turning on an anchor 2. Waters, the headway of the vessel is reduced. Anchor let go on the run. Vessel brought up with the cable leading aft. The vessel is then steamed around the anchor. This procedure can be done when leaving the anchorage too. Difference being when leaving anchorage, the cable is heaved up until it is at short stay, cable length of about 3 to 4 shackles, before giving helm and working on the engines to steam around the anchor to turn the vessel. The vessel's engines are worked ahead with hard over on the side you want to turn. Crash stop. This is an emergency stopping maneuver. The vessel's engines are reversed from full ahead to full astern. The ship is largely uncontrollable during this maneuver, and its path is dependent on the ambient conditions. The track and head reaches and the vessel's lateral deviation are normally given in ship maneuvering data tables. Crash stop is normally executed only during sea trials. Rudder cycling / fishtailing. Rudder cycling is most effective way to stop a ship without changing the heading, done to reduce a vessel way in the water. The rudder being put hard over from one side to the other. Normally done to reduce the speed of deeply laden tankers when they approach anchorage and/or a berth. Watching transits. Transits in line. Two transits in line are useful to check a vessel's drift. These are used when berthing or when proceeding along a narrow channel. When the two objects, front and rear mark, are in line, the ship is on track. If the rear mark shifts to the left, the vessel is to the left of the track, and vice versa if the rear mark shifts to the right. Watching transits. Transits abeam. These are used to check a vessel's speed. Observe the background behind, rear mark, and the front mark. If the background, rear mark, seems to move forward, vessel is moving ahead. If the background, rear mark, seems to move astern, vessel is moving astern. The vessel has stopped if the background, rear mark, is stationary. Watching transits. Transits to clear an object. View of several background objects are helpful when checking whether a vessel will clear an object ahead or not. This is especially useful when turning a vessel in an anchorage that has several ships. To check, observe the point of clearance. If objects behind the point of clearance disappear from your view, you will not clear. The vessel will clear if objects previously obscured from your view begin to appear. This is demonstrated in this animation. Watching transits. Transits to clear a danger. Two transits in line are useful in checking whether a vessel clears a danger or not, as shown in this animation. Speed during berthing. When approaching the berth, the vessel's speed should be adjusted to ensure that she can be stopped by dropping an anchor. Note: an emergency that is required if the engines do not respond in time. Anchoring in a strong current with minimal space. Do not anchor with the stream. Always stern the stream and stream up close to the vessel ahead before dropping anchor. Do not cross the bow of vessels at anchor. Distance covered. The ship will carry her way longer after the propeller stops when heavily laden. Damage caused under impact. It causes greater damage under impact due to the weight of the ship and its momentum. Effective wind on ships. Wind has a great effect on a vessel when the vessel is lightly loaded. That vessel has large amount of side lift and skid. Engine response to load. A loaded vessel is sluggish to engine movement, while a light vessel is responsive to engine movement. Anchor response to load. A loaded vessel turns slowly on an anchor, while a light vessel turns quickly on an anchor. propeller response to load. It is easier to start and stop the propeller when it is fully immersed in water. It is harder to start and stop the propeller when it is not fully immersed in water. Performance. Ships handle best when 2/3 loaded and trimmed by the stern. Berthing is the process where a merchant vessel proceeds alongside. Maneuvers are for a single screw ship with right-hand fixed pitch propeller. Procedures to be followed when berthing in calms at port side and starboard side. Berthing on port side. Approach the berth at controllable speed. Head for the point where the bow finally rests. Approach angle must be about 10 degrees. Engine is stopped when the bow is in a position where the vessel's midships will be. Watch your transits. The transverse thrust will swing the bow to starboard when going astern, right-hand propeller, fixed pitch. Vice versa for left-hand propeller, fixed pitch. Send out your lines. A must to check the vessel's swing to starboard. Spring is the first line. Berthing on starboard side. Approach at controllable speed at a fine angle to the berth. Watch your transits. Develop a port swing before stopping engines. The transverse thrust counteracts the swing to port. Lines are sent out and the vessel is heaved alongside. Unberthing is the process of removing a vessel from the wharf. Maneuvers are for a single screw ship with a right-hand fixed pitch propeller. Procedures to be followed when unberthing in calms at port side and starboard side. Unberthing at port side. Single up to a line and a spring forward and aft. Let go all lines aft. Line forward to cant the stern of the vessel away from the wharf. Cant must be at least 40 degrees. This is by going dead slow ahead on the engine with rudder put hard to port. In this case, the spring must be a good strong line. After the stern has canted out sufficiently, let go the head line. Put the engines on dead slow astern. Let go the spring only after vessel has gathered sternway. Stern first. Note the transverse thrust will straighten the vessel. The reason for a large stern cant. Note, ensure that the bow does not touch the wharf when opening the stern. Unberthing at starboard side. Single up to a line and a spring forward and aft. Let go all lines aft. Heave away on the headline forward to cant the stern of the vessel away from the wharf. Cant must be about 20 degrees. This cant can also be achieved by going DS ahead on the engine with rudder put hard to starboard. In this case, the spring must be a good strong line. After the stern has canted out sufficiently, let go the head line. Put the engines on DS astern. Let go the spring only after the vessel has gathered sternway. Clear the wharf, stern first. Vessel will continue to swing to starboard. Complete the 180-degree swing, if required, after which the vessel can be conned to her final departure course. Note: Ensure that the bow does not touch the wharf when opening the stern. Important point. It is preferable to leave the berth stern first in calms for the safety of the propeller, though not a must. The maneuvers described are the most preferable, but a ship handler could leave the berth bow first if he so desires. Tugs improve the safety of a maneuver. Tugs can be used to push or pull a ship. They have powerful engines. While pushing, they normally push at positions marked on the vessel. Pushing. A. When pushing force is applied at the center of gravity, the vessel will move bodily. However, if applied slightly out of position, one end will swing while the other end remains stationary. B. When a strong wind is blowing on the other side of the ship, the tug should position itself slightly forward of the vessel's center of gravity to correct the swing of the vessel's bow downwind. To swing a vessel, pushing is better than pulling, provided the tug is positioned forward of the vessel's center of gravity. C. A pushing effect at the stern to swing a vessel is not effective, because she may not be able to get too close to the stern, and normally the vessel's center of gravity lies aft of midships. When pushing, the tug's fore and aft line should make an angle of roughly 70 degrees with the vessel's fore and aft line. The effect of the tug's headway will be partly to push the ship and partly to push it astern. This stern movement must be counteracted by working the engine ahead. Pulling. A pulling force is effective when a tug is used to heave a vessel away from the both. The tug line must be a right angle to the ship's fore and aft line for this to be effective. When casting off the after tug, it is essential that the vessel has headway. There is no need to stop the engine during this procedure. Girding. Occurs when a tow line under stress is allowed to lead a beam from the tug. Girding could result in the tug capsizing because of her inability to turn. The line is secured very near the center of gravity of the tug. Girding occurs when the vessel suddenly moves ahead or astern after being pulled away from the berth. The girding process is shown in this animation. Girding can be avoided if a gob line is used or the vessel gives the tugmaster ample warning before moving ahead or astern. Tractor-type tugs are not affected by girding. Precautions to be taken. When employing tugs, it must be borne in mind that tugs will be unable to correct an excessive shear. For this reason, speed should be kept to a minimum. Tugs enhance the safety of a maneuver. Berthing with one tug. The tug is made fast on the bow on a short line, push-pull position. When approaching in calms, approach at controllable speed. Vessel moves bodily towards the wharf with tug pushing forward, DS ahead on engine with outboard helm. Watch your transits for checking speed of approach. Vessel can be made to move bodily away from the wharf with tug pulling forward. DS ahead on engine with inboard helm. Done if approach towards wharf is too fast. Berthing with two tugs. Easiest of all maneuvers. Tugs are made fast forward and aft in a push-pull position. Berthing with 4 tugs. 2 tugs fore and aft made fast on a long line, center lead if possible, to pull the vessel away or to give a head or a stern movement as required. 2 tugs are placed in a push position forward and aft. This procedure is used for loaded tankers, VLCCs, ULCCs. Berthing with thrusters. If one provided at the bow, berthing procedure similar to 1 tug on a short line, while if provided with one at both the bow and the stern similar to the 2 tug procedure. For the effective use of thrusters, the vessel's speed should be less than 4 knots. Unberthing with 1 tug. Make fast the tug with a long line forward, single up to a line and a spring. Let go all lines aft and then open up the stern by heaving on the headline with the spring tight. Once the stern has opened out by about 30 degrees, ask the tug to keep his line tight. The lines are cast off forward once the bow starts moving out. To move the vessel outwards bodily, use inboard helm with dead slow ahead on the engine with the forward tug line kept tight. Unberthing with 2 tugs, bow first. Make fast the forward tug on a long line and the aft one on a short line. Push-pull position. Single up to a line and a spring fore and aft. Then let go your lines both fore and aft. The after tug keeps the line taut and the forward tug pulls at half speed. The ship turns slowly forward. With the engines turning at dead slow ahead, using outboard helm and the aft tug pushing and the forward one pulling, the rate of turn will increase. The tugs can be cast off when the turn nears completion. Unberthing with 2 tugs, stern first. Make fast the after tug on a long line and the forward one on a short line. Push-pull position. Single up to a line and a spring fore and aft. Then let go your lines both fore and aft. Forward tug to keep the line taut after tug pulls at half speed. Ship turns slowly at the stern. Dead slow astern on the engine with forward tug pushing and after one pulling, increases rate of turn. Tugs let go when the turn nears completion. Important point. Remember the vessel will hit the wharf when turning off the wharf. If she has 0 headway, bow turn or no sternway, stern turn in calm waters. When turning, ensure you have sufficient clearance from the wharf. bank cushion and suction effects must be used to an advantage when negotiating bends in a current. Effect of current from ahead. When rounding a bend with the current ahead, a vessel must keep close to the bank for reasons shown in this animation. Effect of current from astern. When rounding a bend with the current astern, the vessel should keep close to the point for reasons shown in this visual presentation. Precautions to be taken. When rounding a bend to starboard with the current astern, the current will catch her on her starboard quarter, shearing her to starboard. If now the engines are reversed, the starboard swing is aggravated and she will align herself athwartships to the tide.